Now we're going to learn about the names and formulas of compounds. This is actually we're gonna have 3 videos in this set to sort of break it up for you so that you're not bombarded with too much information all at once. But before we start, you have to know the nature of the compound. How do you know if a compound is ionic or covalent? I talked about this in the last video. And you have to know this, otherwise the rules that I'm going to teach you are not going to make any sense. So you have to remember that an ionic compound is made up of a metal and a non-metal. Okay? And then a covalent or a molecular compound never has any metals in it. Instead, you have 2 or more non-metals. If you cannot keep that straight, you're going to have a lot of difficulty with naming. So make sure you know the difference between a covalent compound and an ionic compound. So firstly, we have common names and what we call IUPAC names. So common names are derived from the property of the substance and basically differ from language to language. So a couple of examples here are lime and limestone. So lime is actually calcium oxide, but if I didn't tell you that, you probably wouldn't know that. And limestone is calcium carbonate, CaCO3. And again, if I didn't tell you that, you wouldn't be able to figure that out just by the word limestone. So basically what happened, as more and more compounds became known, we discovered a need for this sort of general systematic method of naming. Hence the word IUPAC, which stands for the International Union of Pure and Applied Chemistry. And it is this system that is used all over the world so that everybody knows exactly what is in a compound. There are still compounds that are referred to by their common names, such as water and ammonia, H2O and NH3. But if we use the IUPAC rules, then these become dihydrogen monoxide and nitrogen trihydride, respectively. So we're going to learn about how to name that, and so you can start to get used to those. So we're going to start with binary covalent compounds. So remember, a covalent compound is 2 or more non-metals. Okay. So when you have a compound with 2 or more non-metals in it, you're going to use prefixes to name it. So here are the rules. Number 1, the element with the lower electronegativity is written first. Number 2, you remove the ending from the name of the second element and add IDE in its place. And then number 3, the number of atoms of each element is indicated by the following prefixes. So if you have 1 of that element, it's mono, 2 is di, 3 is tri, 4 is tetra, etc. You won't see anything in this course much higher than usually 6, but I do ask that you know all the way up to 10, so know all your prefixes there. So note, mono is omitted when it is associated with the first element in the compound's name. So for example, an O or an A of the prefix can also be dropped. So for example, carbon monoxide, the formula is CO, okay? So if you look at it, we name the first element carbon. Then we name the second element, which is oxygen, but we have to change the ending to IDE. So instead of writing oxygen down, I'm actually just going to write oxide, okay? And then we have to tell, using prefixes, how many of each there are. So I have 1 carbon and 1 oxygen in this formula, so it would be monocarbon monoxide, but I always drop the mono at the beginning. So in this case, I would leave the mono off at the beginning, and instead of calling it monoxide, this would just be, I would drop the extra O. Okay, so that's what I mean in that second sentence there, okay? The O or the A of the prefix is also dropped, okay? So that's how we get carbon monoxide, and the formula for that is CO. So, oh shoot, I thought this was going to be something that I could show you one at a time, but here are a bunch of examples of binary covalent compounds. I believe these are in your notes, and you shouldn't have the answers. So what I'd like you to do is pause the slide, try these on your own, and then check to make sure you got them right. All right, next is binary ionic compounds. So remember, an ionic compound is a metal plus a non-metal. So we use the stock system usually, and here are the rules. Number 1, you name the positive ion first, then you name the negative ion, and again change the ending to IDE, just like with covalent compounds. But for number 2, Roman numerals are used to indicate the valence or the charge of the element, which may have more than 1 valence. Okay, so another word for valence is its charge. Okay, you can use you'll see both of them, so just in case you're wondering. For elements that have only one possible valence, the Roman numeral is not used. So I'm going to show you some examples of that. Okay, and you should have seen this before as well in grade 10. So you're going to find your charges, and then you're going to crisscross the charges to find the subscripts for the formula. So if I'm combining, say for example, aluminum and oxygen, aluminum has a 3+ charge, and oxygen has a 2- charge. If I crisscross those charges, like this, or the way I've kind of drawn my crazy loopy arrows, you'll get a formula Al2O3, okay? Molecules must overall be electrically neutral. That's why we do this crisscrossing. So that means the total of the positive charges has to equal the total of the negative charges. You also have to remember to always reduce, okay? So if I end up with something like calcium oxide, which was lime, calcium has a 2+ charge, oxygen has a 2- charge. When I crisscross those two numbers and I bring them down to make subscripts, I end up with Ca2O2. I have to remember to reduce and divide both of it by 2 and reduce it down to just CaO. Okay, my next slide is again going to have a bunch of ionic compounds. What I suggest you do again, you have a bunch of blanks in your notes, pause the video, fill in the blanks, and then I will show the slides really quickly so that you can check your answers. So here are the answers for the first ones. So you can pause the video and check those. And here are the answers for the second group, okay? That's pretty much the entire video for today. We're going to go through a lot more examples in class. But you'll notice on this last slide, just before we end, that I have numbers in the form of Roman numerals in brackets, okay? That's what I meant by the multivalent charge. So lead 4 oxide means I'm using Pb4+. So this 4 tells me the valence or the charge. And then I know that oxygen has a 2- charge because it's in group 16 on the periodic table. So when I crisscross these, I get Pb2O4, and like I just said on the last slide, we have to reduce that down to lowest terms, so that's how I get PbO2, which was my answer that I gave you up there. Okay, so again, if you didn't get any of these answers or some of these answers, or if you have questions, make sure to ask in class and get those sorted out before moving on.